want to compute. Yeah, so let's look at the first one. I think most of you are able to solve this. Simply it's asking check if the bitwise OR has trailing zeros. So you are given a number of positive numbers, nums. You have to check if it is possible to select 2 or more elements in the array such that the OR of this has at least one trailing zero, right? For example, the bitwise this, which is this, does not have a trailing zero in this. Okay. So this is fairly simple and straightforward. It's asking that it should have at least one trailing zero. So at least one means at least the last digit needs to be zero, right? So we have to simply think about these numbers as either zeros or ones, odd or evens. And then if there are any two numbers which has zero at the end, then it is possible to have a zero at the end, right? That's what is being asked, if I'm not wrong. Select two or more elements whose bitwise OR is has trailing zeros, right? So if I just simply put this down, there are multiple good versions of this problem that could have been created, but then this is way simpler. It's basically saying ki, you have to have a trailing zero. So A, let's suppose, has some X, Y, Z, and some B number has A, B, C. If you XOR them and it should have a trailing zero, then this should be zero. So this XOR this needs to be zero for sure. So Z XOR C needs to be equal to zero. OR is zero, which means neither of them could be an one, which says Z is equal to zero, C is equal to zero. So you are basically looking for numbers which are Z and C equal to zero. And from there you can kind of deduce, can I pick two numbers which has zero at the end, which means both of them are divisible by 2. So are there two even numbers in the array or not? That's what this question is asking from you. Are there two even numbers in the array? Yes. Are there two even numbers in the array? Yes. Are there two even numbers in the array? No. That's what this question is asking. Clear? This is how you deduce from the expression what is actually being asked. I mean, this is a very confusing statement. No? Two or more elements or has at least this. So this is a very, very simple deduction. Are there two even elements in the array? Okay, a very, very good follow-up that could have been asked, but hasn't been asked is how do you count number of pairs, number of subsets which has trailing zeros? Find the number of subsets of this array. Okay, subsets means how many subsets or subsequences you can create whose OR will be having trailing zeros. How do you do that? Over here, there is any, right? Any. I'm saying count. Count the number of subsets where you choose two or more elements and their bitwise OR is zero in it. And choose two. That will be just pairs. Subsequence means you can have three numbers also. Yeah. 2 to the power even number. Yeah, that makes sense. But then you'll have to remove few things. Number is 0 elements, 1 element. So yeah, I think Roshan, that's perfect logic. You need to get 2 to the power even minus every set which has a single element, they are not allowed. So all the even elements that are present, count even is, let's suppose, the count of even elements, right? Minus 1, empty subsets. So empty subset will also have a 0 at the end. Single element which has 0 at the end also will have a 0 at the end, but these are not valid. So we need to check for subsequence which has two or more. Okay. Yeah, I mean, depends on how you frame it, but in this question, it is asked two or more elements. Okay, so I was thinking of that. Subsequence by its nature means you can also have one element. So depending on the question, but then it could have been a follow-up, right? So if you take any number of elements which has 0 over here and you take any subset out of that, it will have 0 only at the end. But if any of them has 1, then it will become 1. So that will not be valid. So you have to make a subset out of the elements which have 0 at the end. Okay, so this is like a straightforward problem. And I think most of you should be able to solve this. Next, let's move to this. So I'll just quickly read these problems. I've not read it. You have given string s and consists of little lowercase character. This a string is called special if it is made of only single character. For example, ABC is not special, whereas the string written the length of longest special substring of s, which occurs at least thrice. Okay. If there is no special substring, at least thrice. And what's the next version? Hmm. Nice. Okay, so I hope everybody is able to solve one. I don't even I think need to explain the one. Like you can take all subarrays and put them in a map and then do the same thing. No, just take everything, put it in a frequency map. Yeah, this is a subarray, this is subarray, this is subarray, and if it contains same character or not. All those things you put in a map. If you get like anything having more than 3 frequency, you are done, right? So basically, the code will be from I to J. If all of them are same, put that length in the map. Put that string in the map, not the length. String in the map. And for every subarray, do this. Anything that has greater than 3 frequency and has the maximum length will be the answer. Right. So this is, I think, straightforward. I mean, do I need to explain this more? Can we move to the next one? Click +1 if this is clear. How will we do the brute force version? 50 version. Okay. Let's move to the next one because I think next one is more interesting. Right. So here there is just one small observation, right? That like if you have a big length, what you need to think about is what can go wrong, right? I mean, why something might be difficult to compute. So the reason why something might be difficult to compute is something might occur too many number of times. So let's suppose there is A, something like this, right? So over here, what you see is like, let's suppose this is present over here. It might be present somewhere later too. Okay. In the some other continuous chunk of A's again. So first of all, we need to think about is if you have a x length of A's in continuous chunk, my answer will always be bigger than x minus 2. Is this first of all clear or not? If my length, if I get a continuous chunk of length of A, my answer will at least be x minus 2 because this I can very well make. X minus, like obviously if x is greater than equal to 2 only, only that, then I mean to say this. Okay. That x minus 2 length is a valid answer for sure. Okay. So that can be taken care of separately. Now we have to only take care of things that appear twice in a chunk and a single time, which means if there is A, 3 A's appears twice, 4A appear once in this. And then you know that one of the best case answers that you have right now is 2 A's. Is it not? Yeah. Thrice as in Avinash, which one do you mean thrice? So 3 A's appears twice, 4 A's appears once, and then 2 A's to answer. It appears thrice because you have 1 A, 2 A's, 3 A's, and it's a valid answer here itself, right? So this is what we need to check. Can we get these? If not, at least this is the best possible answer that you have, right? So you have to just make sure that we check these correctly in some sort of map, and then this is valid answer. So for every continuous chunk of a character, you will get 1, 2, 3 things to check for. Can you make this as a potential full 3 count 3 times? Can you make this 2 times, 1 more time? And then this is always a valid answer. If nothing works, then this is possible, right? So this is the three things that you will maintain. So what we'll do is we will go through each chunk of the same character. The way to do that is when you have a string like this, A, B, A, C, C, D, right? You put a character over here. I'm making this also A. Then you keep a second pointer J at the same character and keep moving forward as long as it's not equal. So J moves over here. Okay. And then you say ki J minus I, 4 length is of the same character. So you get 4A as one possible chunk. And then move your I over here. Then again, keep moving forward J till the point you don't get the same character as I. This is length of 2, J minus 2, J minus I will be 2. So C, two C's you get over here. And then you move this I over here. You keep moving forward till J is not equal to the last character or it's outside the thing. Over here, this is one length, 1D, something like that. So this is how you partition the string in terms of same character chunks. Then from over here, the potential list is you get 4A once, 3A twice, and let's say I'll just put 2A thrice, right? And I don't need to go through anything less than this because at least this much 2A will be my answer. This chunk will give me 2C once, 1C twice. I don't think get anything more than this. This chunk will give me 1D once. For every chunk, do these things and put all of these things in map. 4A, 3A, and 2A. So in the map, you can build this and then simply check ki, acha, for A, which is the highest like length did you get with greater than 3 frequency? For B, what's the highest? C, what's the highest, and so on. From there, you can calculate the answer directly. But then the idea for this one is not to go through all subarrays, but just understand that same character chunks will give only 3 possibilities that you need to check for. X, X minus 1, X minus 2. That is the main observation of this problem. Clear, everyone? So let's try to, where is the question? I mean, this will be directly solved in that sense. Nothing much to do. But then if required, I'll code the solution. Okay. Should I code this problem later on? Once we discuss even the second logic? Okay, I'll code the solution. Okay, what to do exactly over here. Can you binary search on length and check using rolling hash? I mean, why even rolling hash? You can just simply check if they all need to be same character, no? So you can check if they are same or not. Yeah, you can also use binary search for this problem. Binary search plus sliding window will also work. I mean, I think this problem was supposed to be solved this way because it's easier to do. But yeah, binary search also works. Using map will give the TL, you'll have to use some numbers for the substrings. That's the problem. Rolling hash kind of thing you'll have to use. Or check quickly using prefix sums and stuff, maybe. So let's code this up only because since we have discussed this right away, I'll just directly code it because then only it will make more sense. We can have -1 also answer, no? Yeah, because if there is no such thing, then so I will need to break it into chunks. So I'll break it into, so this, how do you break a string into chunks of same characters? I'll just real quick code this and then we'll move to the next problem, right? That would be, I think would be a little better. So how to go through this? Integer I equal to, let's suppose 0, or I'll do this way. What? So the way to go through the chunks is I equal to 0, I less than n, I plus plus. Right? Integer j equal to I, while j is less than n and s of I is equal to s of j, j plus plus. So that's it. Basically, the chunk I till j exclusive will have the same character. This is the chunk that will have the same character. Okay. So I can save it somehow that like, okay. So this is like a compression. This is also a problem in itself. Pair of char comma int chunks. So I can say that I get a chunk of what is the character that is present over here? S of I, comma. I don't need to do I plus plus. And the length would be j minus I. How many of them are present? This is what is present. This character is present this many number of times, and then I needs to move to j. Okay, that's all. This is how you break the string into chunks of same length. This character this many times, this character this many times, and so on. Okay. Now, once these chunks are created, I can simply create a map of like chunks itself. Again, frequency. Okay. So for auto v in chunks, for every chunk that I have, I can put frequency of that same chunk. Like v dot first is the character, v dot second is the number of times that character appears. This appears exactly once. This appears exactly twice. This appears exactly thrice. Okay. And then this is only possible if right. So this is how you exactly write this piece of code that I was talking about. This is called chunking of the whole string. You break it into chunks of the same character value and its count. For each chunk of the same character, you break it into full length one time, one less two times, two less three times, right? And you don't need to, this is exactly the optimization that we are doing. We don't need to go through the rest of the things. And once you are done with this part, there will be exactly O of n chunks that will be available. And three, at most three, shouldn't we also push back in the chunk for its length? Yeah, this is the length, no? Second, v dot second is the length. Acha, in over here you are saying it should be j minus I plus 1. No, so we are stopping when j is not equal. So j has exceeded the point where it's equal to that particular value. So the way it will work is when your I is over here, j will go here. It is starting over here. It's equal, so it will move forward. Equal, move forward, move forward, move forward, move forward, move forward. It will stop over here. Let's suppose. So if it is 0, 1, 2, 3, 4, 5, 6, 6 minus 0 will be 6, which is the length of the number of that equal. So it stops at the first place where it's not equal. So it's exclusive of that j. So this is how you handle the chunks. And then I think it's just a matter of time when you go through this map and find out the highest length. Do we need to print? Can you print any? Why 4a? No, not 4a. I'm just giving an example. If there were 4 a's, so if there comes a 10a, right? If there is a which appears 10 times, so what will say that a appear 10 times once, a appear 9 times twice, a appear 8 times thrice. So 8 can always be answered. If there is again another 8, 10, then maybe that will also count, and then we might have 8, 10 3 times also possibly. Yeah, that is correct. That is dependent. Any special reason to map over unordered map? Because I'm not in interview, that's why I never use unordered map outside interviews. Because people who, if somebody is a good setter, they can make unordered map fail on certain cases. Okay. Well, code forces folks can make unordered map fail on problems. I don't think Leetcode can do that ever, but code forces pe I have a practice, so I don't rely on unordered map anymore. Plus, pair of character comma int directly doesn't have a hash, I feel. So you'll have to create that. So why to go into all of those things? Yes, daily data. Don't use unordered map unnecessarily. Okay. So frequency build ho gaya. And then what to do after this? Once you have the frequency and stuff, just simply go through the map for auto frequency if v dot, sorry for using v everywhere, v dot second. So what is in the frequency? The chunk, comma, its frequency. If its frequency is greater than equal to 3, yes, v dot second greater than equal to 3, then it is a valid sub chunk. In that case, do I need to print the length? I have to print only the length. I'll just take it as -1. And if something is feasible, then best length equal to max of best length, comma. What is the current? So the chunk is in the first, and in the first is the chunk. So the length is in the second of the chunk. So I'll just keep it over here. Let's try to run this code. Let's see if I get a like MLE, as somebody was saying. So it got accepted. You know? So this is how you can do this problem. You don't need so much of binary search and all. Okay. Clear till this point? Okay. So then we are left with only the last problem. So now you are all able to solve 3 problems. Third was possible. The only thing is, this is one piece of code I'll tell you to kind of pick up from me, because I've written it multiple times and it just works correctly. This same use case, chunk till same character, is used in a lot of problems, and you should ideally think about it in those terms. Okay. Now let's move to the last one, which is this. Seems like a big problem. Okay. 0 index string s, even length n, 2D, rearrange the substring this to this. You can rearrange this. For each query I, you are allowed to perform this. It's possible to make the S as a palindrome by performing the operations. Each query is independent of the other query. Makes sense. Okay. Cool. So this is also, I think, a standard idea that when you have to rearrange characters, what do you look at? Okay. This is like, again, when you're picking up the codes, you should try to think about how can you code optimally. If you start writing too much, you will end up wasting too much of time in contest, in actual tests, everywhere. Optimizing code is another thing to pick up in these sessions. Okay. Queries of I to J. I can rearrange. Okay, let's see. Let's take a test case. How to do this? Palindrome prefixum should be sufficient. Let's see. A, B, C, A, B, C. So first of all, let me just check once. Is it given that we can... So one of them is in the second half, one of them is in the first half. So the way I can think about this string is, I will just put A, B, C, and the other one is A, B, C in the reverse order, and these should match. I mean, for this to be palindrome, this should be equal to this should be equal to this should be equal to this, right? And I can think of this being written just below these characters in this way, right? So that this should match with this should match with this should match with this. Correct? Clear till this point? Yes or no? This is how you check for palindromes, right? The first should match with last and so on, right? And it's given its even length. That's first thing that made it easier. I mean, even if it was not, I would have just deleted the middle character and made it the same question. Next, I have to rearrange. So what is now given is you are given some chunk over here, some chunk over here. You have to tell, can you make it palindrome by rearranging things in this case or not? Okay. Okay. So let's take a bigger array for now. I mean, in this case, you can understand, right? If I get 3 to 5, like I can rearrange everything in the second half. 3 to 5 means like everything in second half. So I can make this C, this A, B, and this. This both is like easier cases, so will not give us any information. So what I will think about is, okay, I now know that S is some part 1, part 2, and I'll have to write it in this way, flip in the reverse order of B. And then I will be given some chunk over here, some chunk over here, and I have to tell, can I make these after rearranging equal or not, right? So you are given the indexes like A to B, and like C to D is in the forward way. I mean, if I just reverse it and place it over here, it will be somewhere over here, C to D. And I'm just writing it as C dash to D dash. I mean, we can find the corresponding indices by some algebraic. It's not that hard to find. But then this is something that will come up. So now if I see what is happening, there are few portions created. Right? This part, this part, this part, this part, this part, 5 parts. I think at the max case, when you are putting in, like there are like 2 segments, one whole segment, and you're putting 1, 2, 3, 4 lines somewhere. So you will get 5 parts, right? One where there is none of them covering it, then exactly one covering it, both of them covering it. Is this part clear to all of you? That we will get these kind of segments where none of the 2 rearrangement segments is covering that part. Exactly one is covering, both of them are covering. Clear? Okay. First of all, where in the indexes where none of the 2 ranges are covering it, they should already be palindromes. Correct? Yes or no? These should already be palindromes. Okay. Similarly, this should already be palindrome. Sorry, not palindrome, equal. My mistake. These should already be equal. Character by character. Okay. So we can find out such things quickly too. I'll tell you if this part is equal or not. I'll tell you how to do that. Then this part can be rearranged. So I know what I need to bring. Let's suppose there is an A over here. Okay. I need to bring, let's say some character X over here. I need to bring the X over here. Similarly, if there is some Y over here, I'll have to bring a Y somewhere from over here to over here. Right? So these pieces are fixed. I need to somehow make these the same as these. And then this can be rearranged if the set of the 2 characters are equal or not. If they are equal, then these will be managed. That's not a problem. Okay. Okay. So let's think about how to do this efficiently. I got some idea, but then this is not yet fully baked. I'll have to think about three things. One, how to handle zero, how to handle one matching, how to handle both matching, right? These are the three kind of cases I will get. One more possibility that I can get is there are two strings, like S first half and second half reversed. And I might get a substring like this. And over here a substring like this. So there will be no case where we'll have both overlapping. So this is few ideas that are coming to my mind, which we'll have to check correctly. Are you able to understand these two cases? क्या हो रहा है? What are the cases that are happening in such place? Are the two diagrams making sense? Yeah, अच्छा, there is some S. इतना पोर्शन दिया. So we are kind of taking the half and putting it in the places की F के बाद G है, तो G should be over here, H should be over here, and so on. Correspondingly placing this and then trying to see what will happen over here. So this is S and this is S half, second half reverse. Okay. So from over here, how do we find out the answer? Okay. First things first. Okay. Forget about having this. Forget about having this. How will you check this? Given string A and string B of equal lengths, if you can solve this problem, the other problem is very easy to do. Okay. Let's do this. You will be done with the other problem. There is string A and string B given to you. Both are of equal length. If you can rearrange the letters in the range L to R of A, can you make these two strings equal or not? This is the query that you have to solve. If you can solve this problem, this last problem will be simpler to solve. First, let's try to solve this problem and then we'll go to this. Clear? Is the reduction clear to everyone? That why are we are trying to look at only at a simpler problem right now, and then we'll go to this original problem. The simpler problem is given a string length, a string of A of same length of string B. We need to make both of them equal. The queries that are given to you is if there is L to R characters of A that can be rearranged, can you make A equal to B or not? Is the question. How many of you are clear with the question? Because this is the atomic question. If you can do this, then you can solve the original problem. If you cannot do this, then this is nowhere near. Like you will not be able to solve this problem in contest. Okay. So we need to think of an idea for this. And there are queries of these L and R. Okay. This is the main question. So this is what we will solve today. And then you will go back and you will solve this question, this main wala problem. If you can solve this in class, you will be able to do this on your own. Okay. It's exact same question, but just you have to do it twice. I'll tell you where. A, B, two strings given, fixed strings, queries, L to R. You can rearrange in A, find if you can make A equal to B. Okay. How do you think about this? Number one, I have to check from L plus 1 to N. Let's say 0 to some N minus 1. If you are given some L to R, I have to check R plus 1 to N minus 1 should exactly coincide. 0 to L minus 1 should exactly coincide. Okay. And then from L to R, I have to make sure that the count of characters are equal. Yeah. We'll get into that. Correct. The count of characters needs to be exactly equal. Okay. So the way to check this, there are multiple ways to check this, by the way. But then what I'll use in this case is simply using prefix sums, because that is what will be used in the other problem also. This is a generic way. can L to R of this be rearranged to L to R of this string? This is a very, very common question that might be asked. Okay. Can a substring be rearranged to another thing? If you don't know how to handle such queries, you will not be able to solve such problems in contest. The way to handle such things is to reduce this string into frequency count of the characters. And then this also, and then see if the frequency count is same or not. Because when you can rearrange, it's only the count that matters, because positional ordering is no longer relevant. I can reorder and make it be placed at any place, right? So ordering doesn't matter anymore, just the count or the frequency matters. So when the operation is reordering, the equivalent, like everything can be A is equal to B if the frequency count of the character of the string A is equal to B if the frequency of this part is equal to frequency of this part. And then obviously these are same, right? So then the two strings equivalence depends on the frequency count. So we need to be able to find out the frequency of A in the range L to R, frequency of B in the range L to R, and so on. This is a very standard operation generally done by prefix sums. How do you do it? You maintain 26 prefix sums. For A, you maintain a prefix sum that, hey, A, B, A, B, A. So A is present over here, A is not present over here, A is present over here, A is present over here, A is not present over here. Similarly, for B, you will write B is not present over here, B is present over here, B is not present over here, B is not present over here, B is present over here. So you will create a is B array, is A array, which tells you that is at the ith index, is it a, is it a B, is it a C, is it a D, and so on. You will have 26 such array. And then you will build prefix sum on this. So that if you want to find ki, acha, in this much, how many A's are there, it's just the number of ones, the frequency count, the sum of the subarray. So you will be able to get it from frequencies, prefix sum. Okay. So the way we will solve this problem is look at this part, and this part separately. For this part, we will use this idea. For this part, we will use how many characters are equal, count, is it equal to the length or not? For this part also, we'll use the same logic. This is equal to this, then +1. If this is equal to this, then +1. If the sum of that is equal to the length, that means everything matches. That is how you match, or if everything is exactly same or not. Yeah. Or you can also maintain things like how much suffix, how much prefix is already matching. But then this is a generic way to do this. We are trying to learn generic ways so that you can use it in any problem instead of just this one problem. I could have given you things like, okay, what if I rearrange two parts of the A array, this much and this much, so that you can use this, and this. Using only prefix and suffix, you can only do these two things. You will not be able to use this over here. That's why I'm trying to teach you generic things so that you can use it in any part. So how to check if a part is matching with this? Simply maintain, is the character by character matching happening at each place? Is match 0 or 1, 0 or 1? If all of them are 1, then only this part matches, right? So you have to check all of them are 1 or not. That can be done with prefix sums. All of them are 1 or not. That can be done with prefix sums. Okay. In case you are not, how many of you are not sure with your prefix sum like skills? How many of you are not sure with how good you are on prefix sums? Bhai, to karo. I'll send you this. I think we added this. Yep. Go through this wala part, this master prefix sum and partial sum wala part. Right. I don't know if you have checked out this right anytime or not. Okay. Bunch of things we've added over here. Still in beta, but then can have a look at it. This basically has all the ideas that you need ever in prefix sums. Yes. So I will code this version for you, and then you will have to use it to code the original problem. Okay. So Where is this? Let me code it over here itself. So generally when so I'm no longer solving this problem. I'm looking at another problem, which is, tell me, can't we directly compare frequency maps? Yeah, we can compare frequency maps in this case, but not when there are multiple subarrays, no? Like when there are multiple subarrays being individually rearranged, we will not be able to do it because each of them will need to match correspondingly, right? Not in totality. Okay, so I'll write. कुछ तो भी custom, ठीक है? So I'll custom data structure, something. So what it supports is, let's say, I will be given two strings A and B, and then I'll be given bunch of queries on it. Okay, so I'll write it this way: void init string A and string B. I'll be given two strings at the start, and then I'll be given bunch of queries, and I have to answer the queries very, very fast. Okay, Boolean is same. Okay, is it same if you can rearrange L to R in the string A, or B? Doesn't matter. Like rearranging in A is same as rearranging in B, because as I told, frequency is what we are matching. So that's what we are looking at. Can we rearrange at A and B? And the second, I'll then tell you how to use it to solve the original problem also. But let's first code this problem, because I want to show you some like writing styles on maintaining these prefix sums real quick. So when you are given the strings at the start, that's when you will have to build the structures, right? So there are two things to be matched. One is exactly same. Next is rearrange same. In rearrange same, we need frequency count. In exact same, we need exact count. So is match will build two arrays. Something called is it already a match? And then we will build prefix sum of the character match. So we will build okay. So what we'll do is I'll just go through for integer I equal to 0, I less than n, I plus plus. Obviously we have no n, and so it's fixed by default. Like A and B's lengths are fixed. I mean, it's given they are same. So I'm just putting n is equal to A dot length. Okay. And then what I will do is I'll just go through the length and then say if A is equal to B, sorry, if A of I is equal to B of I, then this position follows is match equal to 1. We'll have to resize things properly, but I'm doing that a little later. Okay, so this is the is match wala string being built. And then character count we'll have to maintain in both A and B. Character count of A, character count of B. By default, everything will be 0. So I will initialize things over here. Don't worry. These things, but then like because or else without resizing it properly, it will give you segment fault. But then when they are matching, they are 1 followed by corresponding characters over here. They will be 0, but the like if there is an A at the ith place, then that should be 1, or else it should be 0. So I'll say character count of A at whatever the character at A of I is, that is present at I, so it should be equal to 1. So what are we building over here? I'll show this real quick to you. Okay. What is this? What is this saying? Let's suppose we have, for the string A, we have A, B, C. So what I've done is, there is a 26 length array which has all zeros. This is the position number 0, position number 1, position number 2. This is A, B, C, D, followed by like this 26 characters, rows over here. For when I'm coming to this, I'm saying that all of these are by default zeros, except for the character A, which is in row number 0, I want to put 1 over here. For character B, I want to put 1 at the corresponding index 1. This is what I'm building over here. For that particular character's row, put whichever index I'm currently in, I'm seeing that this is the character, put that as 1. Okay, this is what I'm doing over here. And then we will build prefix sum across all these things, whatever these things are. Okay, then we'll build prefix sums on these. So for integer I equal to 1, I is less than n, I plus plus is match of I. Why are we building prefix sum? So that we can check ranges together. Is all of them following something? Yes or no? Or you can get aggregates across this character count aggregates. Is match of I plus equals to is match of I minus 1. I'll also have to go through all characters for integers. CH equal to 0, CH is less than 26, CH plus plus, all characters. This is how you build the prefix sums. Okay, this is how you build the prefix sums. And once you have built this thing, let's initialize it also, because I don't want you to be left is so we are creating n size vector with zeros in it. Similarly, for the other thing also, we'll do the same thing. Okay, and then we are just using this is the initialization part, so that everything is created in the vectors, and then we fill the is match, fill the character counts, and build the prefix sum. So this is what the initialization part of it will look like. This is exactly what you have to do in terms of initialization. Okay, and then like once you have done this initialization structure, you can do bunch of things, like you can check. Chalo, let's use this as the function for checking is the L to R of the string A already equal to string B or not. Okay, let's say we have to also support Boolean is same after rearrange. Okay, that if you rearrange L to R, is the part from L to R in the range A is same as B or not, and then Boolean the query integer L to R, that is the full string equal if you are matching with L to R or not. Basically, this will be nothing but return 0 to L minus 1 should be exactly same, and this is exactly this. How many of you got the idea of these two queries? What are these two queries standing for? आई एम ऑन म्यूट। ओके, अब आ रहा है आवाज? जितने टाइम तो म्यूट बता गया मैं। ओके, जस्ट नाउ। ओके, so this is exactly what we are looking for this. Clear exactly you that this is the logic now. We have to just fill these two functions. L2R needs to be exactly same. L2R after rearranging needs to be exactly same. These are two things to support. So now once this is built, these are easy to be done. Why? Let's see. How will you check if L2R is exactly equal or not? So first of all, if L is greater than R, return true. If it is empty, then it's by default same. Okay, if L is greater than R, then it's empty. Same goes for over here because we might by chance call 0 to -1, right? Because L can be 0 also. So in that case, these will be trivially handled. Rest, we have to check for from L to R, is everything matching character by character? The way to do that is using this is match. Okay. If they were equal character by character, all of them should be 1. If ith character was equal to B's ith character, then is match was 1. If the whole range needs to be equal, then all of them needs to be 1. If all of them are 1, then their prefix sum will be exactly equal to the length. So get the prefix sum of this particular array. How will we get that? Simply by finding int prefix sum is equal to is match. We have built the prefix sum already, so I'll just directly use it, minus L greater than 0 question mark. If it is greater than 0, then we'll have to subtract L minus 1, or else we have to write 0. This is exactly how you write prefix sums. Prefix of R minus prefix of L minus 1, given that L minus 1 exists, which requires this to happen. If it does not exist, then it's 0. This is how you write it. Okay. If, and then if, then the number of prefix sum is nothing but how many ones are there. It has to be exactly equal to the number of characters in the length. This is exactly how you solve for is same. What I was thinking, why am I writing it over here? This is for this, no? Is it exactly same? If the character catches should happen exactly equal. Is this part clear? ये कैसे हुआ? How is this working? What I've done is I've saved. Let's run it on one small sample. That will make it even more clearer. Let's see. Right. So what will happen? Is this equal to this? Yes. Is this equal to this? Yes. Is this equal to this? Yes. Is this equal to this? No. Is this equal to this? No. So now if I get a subarray sum query like this, it will give me 2, but the length is equal to 3. So this is not equal. But if I get a subarray sum like this, it will be 3 and the length is 3. So they are actually equal. This is how I'm checking it. So subarray sum, prefix sums is something that can be used for this. Clear, everyone? This is the whole logic. Okay. For rearrange, I have to just build the prefix sum count of the both the parts. So that's what I will build. Let's see. LR rearrange. Okay. So to rearrange this, I'll have to get the character set. How do I do this? So frequency of characters, there are exactly 26 characters and all of them are by default 0. frequency of characters in A in the part L to R. And then I want to also do the same thing for B, right? So what will I do? I'll just simply do this. For integer I equal to 0, I is less than n, I plus plus, not n, 26. I'll go through all the characters one by one and see how many times they are present in A in that range and B in that range. And they have to be exactly equal. I don't even need to build this actually. Int A count of this character is nothing but the character. I should ideally write this as the same variable so that you can later on follow on easily. From L to R, so R minus, again the same thing, L greater than 0, question mark. This for the L minus 1, if it, subtracting the last part, if it exists. If any of the characters mismatches, then it is not possible to rearrange it, or else it's possible and return 1. This is basically the whole logic of matching something, two strings parts exactly, are they equal or not, without using anything hashing and all. Okay. Based on the queries, and then some parts in terms of if the characters can be rearranged to the same thing, the counts are exactly same or not. If at any for any character the count is not equal, then it is not possible to do it. If all of them are same, then it is possible. So I can return false and true. I mean, 0 and 1 anyways will be converted to Boolean. Doesn't matter. So this is the main structure that you have to use for this problem. Clear? And now I'll show you how to use it for the original problem. But then, is this part clear to everyone? I'll paste this code somewhere. Should I post it on the Telegram? Because that's the only common chat. And then I'll give you the idea. There is no code highlight, but anyways. Chalo, okay. I've pasted it in the Telegram. Paste bin would have been better. Sorry. I think I will. Chalo, ab dal diya. Right. Let's keep it that way. Now let's come to how do you actually think about the original problem. It's way, if this is done, then the rest of the problem is super easy. Can you think about why? It's just about finding the correct indexes now, because rest everything we have already solved. And let me show you how this is going to become exactly equal. So this is basically saying ki you have to check for two parts, no? It's just this index, guys. See, there is a string A, there is a string B. You are said in these, this is the reverse of that, obviously, half parts reverse B, and you are said that this much and this much might be given to you. So when two intervals are given to you, or let's first take this case. That this much and this much can be rearranged. Okay, can you tell, you have to tell me whether they are same or not. Quick question. If I shift this to this, is it the same question still? Yes or no? Will the answer remain the same? Are these two strings equal if you can rearrange this and this? Or if I just move it over here, same string, same positions, I can rearrange this portion and this portion. Tell me if these two strings are same or not. Are these two questions going to give you the same result? Yes or no? Right? Yes, because A, B, C, A, C, D, E, F, A, C, B, A, C, E, D, F, right? If I let you rearrange these to make it this and this to make this, I can simply also think about these two are same because I can rearrange. Even if I let you move this to this is still going to give you yes, right? Because I can rearrange it the other way around. Look, I would have changed this to the correct places. I'll change this to the correct places now, right? Is this part clear to everyone? That I can actually move the string from the second half to the first half if I require it. And then now we see the second case also, which is what if things like this is given to you, wherein this is present in such a way that they are overlapping. What do you think we can do? Are you sure we can merge intervals? Rearrange the union. No, this is not equivalent. That's what I was going to come to. They are not, they are not equivalent. Let me tell you why. Because what if there was an F over here and there was a F over here? Sorry, F over here. Okay. In its original question, you could not have brought this F to this place, no? Because you can rearrange this and rearrange this individually. But then if you take it together, then it is not possible. So I cannot say that this problem is equivalent to, I will not say that this is equivalent to this. Okay. I will not say that this is equivalent to this because it is not. Okay. Instead, it will be three pieces broken into in each sense, sort of. Okay. Not even exactly that. I'll tell you what exactly we'll need to do. See, from this piece, I have to make sure that this much piece at least matches, right? From this much piece, I can try to check out this much part. From this much portion, I have to make sure that this much part matches exactly. And then whatever is left, I can use the frequencies to match this part. So from the whole this region, I will get the frequency count and I will see how much do I need over here. I will have to take it out for this part. From this whole region, I will get the frequency count. Whatever parts are static, I will have to make sure that I match them. So those frequency will then decrease. Whatever is left, they need to be same. Does this make sense to all of you? What exactly needs to be done if they are overlapping? The common part can supply things to both the parts, right? So you cannot remove the common part altogether. Think it this way. Let me put it this way. Okay. So if I have this and this, I will not remove the common part. I can think about common part being used for this much, right? It should match, it should help us to match this much. So I can take out a B, take out a C, and in the common part, A will be left. In this part, I can take out a C, I can take out a D, and take out a E, and then A will be left in middle part, and they will be exactly equal. So from the left hand side, from the right hand side, whatever part are extra, I need to first of all make sure that those many things can be taken out in terms of the count of characters. Whatever is left in the middle part, they need to match. This is exactly what we will have to check. Clear? अब तो एग्जांपल दिखा दिया, अब तो क्लियर होना चाहिए. हुआ क्लियर थोड़ा थोड़ा? एक बार खुद से दिखना पड़ेगा कॉपी पे करके. I mean, you'll have to write it on a notebook once and then see how's it working exactly. But then this is the main idea, and both the operations are very very similar to what we have done. Taking out the frequency count, subtracting the frequency count of this, taking out the frequency, so that will be left part. In this part also, take out the frequency count of this minus this. That is the left part. They should match. This should be sufficient to match this. So that is what you can do for to custom check exactly this. So we'll have to write a separate function L R L1 R1 L2 R2 and then write logic depending on whether they are overlapping or not. Okay. So this is something I'll give you as a quick home task. If you can do this, then you will have the full understanding of the whole thing. But then which part to apply operation first when we check either of them? Both will lead to the same thing, no? Because here also this is fixed. So the same character set will be removed and this will be left. Whatever will be left over here will be the same thing. You don't need to worry about it. Both part you can do either first. Both of them will work in the same way. You can check the A part first to the B part which is not included in the range, and then B part which is not included in the A range. Okay. Do you want me to write the function? So I'll give you छोटा सा hint in terms of code also, just so that you can maybe write it. I'll not fill it completely. The main query. Okay. There are two cases. If I'll write in comments overlap condition, you'll have to write it on your own. Okay. If the segments overlap or if there is some intersection else, okay. If there is an overlap, then we'll have to handle the condition where there is some overlap. Then you need to find, so whichever one is first, then overlap, then the third, then the second. So in the first one's case, you will have to find the whole frequency count in that range. Okay. This way, 26 characters. And whatever is not overlapping, that part you'll have to match. So let's think it this way. I'm assuming that because order doesn't matter in which one you are given L1 R1. We have already discussed that multiple times. या फिर इसको रहने देते हैं. Let's think it normally. So in the first one, you are given L1 to R1. How much portion will not match? You have to find it out. Overlap, you will get the overlap zone. Based on that overlap, you'll have to write what is the character set. I would have ideally created this, a function, which gives me a vector of 26 returned. Frequency count 26 0. This is the frequency count of all of the characters in the range L2R. So I'll get 26 length characters set for the L2R. What is the frequency? If I ask for A, for B, whichever one I will tell, it will find me the frequency count of that. And based on that, I can simply find out whether the things will overlap or not. So what will I do? I will just find out the character set of L1 to R1. Frequency set of. So I'll find out the part from A. A. This is for A. So I will get the portions frequency count of characters for A. For that, whatever characters, whatever portion is there except the overlap in B, I will try to match it with that. Remove the portions that is required for that. So this will be character frequency of B from, I'll write it over here. These all things you will fill. L1 to R1 minus overlap. Okay, this is exactly what you will need to remove from this. And then remove it from A, delete it from A. Okay, if you cannot remove, then it will not be possible. Then same thing for B. After removing, they both will be same ideally. I mean, if the whole character set is same. So you just check. So this minus this should be equal to this minus this. And first of all, this should be able to, we should be able to minus this from this without making any character frequency negative. If that is not valid, then it will not be possible. We should be able to remove this from this without any change. And then whatever is left, they should match. So A left will be character by character difference of this to this to this. Whatever is left, they should match. Left should match. These are the 3 steps that you will have to do in this case. The rest, everything will be same. Clear? This is the main logic for overlap. Non-overlap to directly just or wala condition. This just add another in between. There will be a is same, and then there will be another is a range of L2 to R2. Right, depending on whichever one is first or second. Clear? This is exactly the logic that you'll have to fill in. I mean, I can go ahead and fill this also, but I'll leave that to you. Okay. And this one I'll just quickly do with paste pen. I'll send it in the chat too for you all and on the Telegram as well. Arrays and string lectures. That's in 6 o'clock, no? How come that will form? Because we are taking, because all of this is happening in S by taking this in the reverse order over here. This is being placed over here, this is being placed over here, this is being placed over here. So this will match with this will match with this will match with this. And that is why. A good question to leave in OS. Yeah, I mean, this will be, I mean, try brute force in OS. try brute force first, because I have seen that in Leetcode also there will be some brute force that will pass for this one. What is pure virtual function? I don't know. I don't know. Google karo. Yes, if you are using the DP workshop, then I'll show you. If you're following the DP workshop on YouTube, then there is this like DP workshop that is available over here, which has all the day's questions available. And I think you would not know about this site. So I'll just send you the link, which will contain all this. Okay. So this is, I think, the place where we'll stop for today. This is the DP workshops practice set. If you are following that. Leetcode past problem source. I didn't get your question exactly. But then this will be it for today, I feel. We'll stop over here and for the recording.